We've all been there. Your video buffers midstream, a call drops, and upload stalls. You're experiencing wireless technology at its limit. But what if wireless networks could learn from real-world conditions, adapt in real time, and improve with every single connection? This is exactly what Qualcomm Technologies and Nokia Bell Labs are working on together. They're collaborating to advance wireless AI by developing systems that continuously learn and evolve in real time, spanning diverse devices, networks, and technologies. Behind the scenes, every time your phone receives data, wireless networks are constantly checking, did that message arrive correctly? This checking process is one of the most critical protocols in wireless communications, and it's called HARQ, which stands for Hybrid Automatic Repeat Request. The intended receiver checks for errors and sends feedback to the sender, but sometimes the data doesn't arrive perfectly, so it sends a NACK message, meaning send it again. The transmitter then resends the data, often with the extra information to help fix the errors. The data is then correctly received and an ACK, acknowledgement, is sent, meaning got it.
In today's 5G system, the ACK or NACK feedback is turned into a stream of bits, zeros and ones, which are linearly encoded. This coding function treats different ACK and NACK input sequences equally. But the real-world feedback isn't always uniform. Probabilities and reliability targets differ for different ACK and NACK input sequences because conditions change. So if the network doesn't receive ACK and NACK correctly because the channel conditions are severe, that can cause unnecessary retransmissions because the ACK wasn't received properly, or outages and unreliability because the NACK wasn't received correctly.
With AI-based joint source and channel coding, we train the feedback to better understand the real-world patterns. This improves efficiency and reduces errors, leading to more reliable 5G links and potentially even stronger performance in 6G in the future. The new AI-based approach enables direct mapping of HARQ feedback bit sequences to modulated waveforms with different TX power, optimizing for known source distributions such as ratio of ACK and NACK bits and the correlation of error events across time. Once the AI encoder is trained, only a lookup table is needed, which leads to fast and efficient encoding.
Here you can see a prototype radio from Nokia Bell Labs communicating with the mobile test device powered by Qualcomm Technologies. This setup shows how an AI-based joint source channel coding JSCC approach demonstrates how the process can improve 5G performance and potentially 6G, even as conditions become challenging. To make this work, the joint source and channel encoder, including a power shaping step, has been trained for different environments. The resulting lookup table is now shared between the network and the device, allowing both sides to adapt together as conditions change. For a fair comparison, the same input sequence is used with both the classic 5G as well as the new AI-based JSCC approach, which may help in 6G in the future. Different ACK/NACK waveforms are transmitted by the device and received by the G-Node B over the air.
Results show that AI-based JSCC reduces both ACK to NACK and NACK to ACK errors compared to classic methods. That translates into a more reliable user experience. And importantly, joint source channel coding powered by AI/ML can be trained and shared between network and device, enabling robust, efficient feedback for future air interfaces.
As we move towards more intelligent, AI-driven wireless systems and 6G, these advancements are laying the foundation for step-change improvements in reliability and efficiency.